So friends, so this is the preparation for the strength of materials. So what is strength and what is material? Strength is basically the maximum stress value given to a material till its failure point. It is called strength. And the material we are basically talking about the engineering material, which has some mechanical properties and physical properties. And we are talking about materials like ceramic, steel, iron, aluminum, any metal and non-metals also. So we are basically talking about the solid body, which shows some internal resistance to the given applied forces. We are not talking about the fluids, because for fluids they don't have intermolecular resistance or intermolecular force. They have basically the cohesive or collision forces. We are basically talking about the solid bodies only. So when we are talking about the strength, what is the difference between the stress and the strength here? So stress is basically the resistance force applied on a particular area, and while the strength is basically the property of the material. So the stress basically changes with the applied force, not the resistance force but the applied force. But the strength of the material won't change with respect to the applied force, because it is basically the property of the material. So basically what we call the stress is basically that it is basically induced into the material due to the applied force. When the force is applied on the body, due to the change in the intermolecular distance of the material, the cohesive bond between the molecules resist to the changes, which in return creates the internal resistance, and that internal resistance is called as resistance force. That resistance force induces the stress in the material. So here the resistance force is basically the output, and the strain is basically the input. So in the when we are coming to explain the strength, we can take an example of the stress and strain curve for the mild steel. So we can see from the diagram that from the stress and strain curve we can get some of the strength of the material called yield strength, ultimate strength, and the failure strength. So basically the lower yield point of the material is called the yield strength, and the other one is the ultimate and the failure strength. Okay, and there are basically types of stresses. Those are normal stress and the shear stress. In normal stress, basically two types of them: tensile and tensile and compressive. Tensile and compressive both are basically normal stress, and the shear stress is when the force applied is parallel to the surface. So this is the shear stress. And can shear force produce normal stress? Of course it can produce. For example, if you take a cantilever beam like this, when you apply the shear force along parallel to the surface, you can see that the cantilever bends. As you see, there is a bend here in the upper portion that creates a tensile stress, and in the downwards there is a compressive stress. So both stress are basically normal stresses. So a shear force can create a normal stress. So this is basically bending stress is basically a normal stress. So then tensile strain. Tensile strain is nothing but when we apply force to the material and there is a change in the length of the material along the longitudinal direction, in which the direction along the applied force, you can see the strain is changed, that is the change in the distance by the original distance, whereas the shear strain is basically the change in the distance along the y-axis, x-axis, and the y-axis. It is called, so we can say shear strain as gamma symbol. And about the modulus of various types, our modulus of elasticity is basically the E is equal to sigma by nu, normal stress by normal strain. So it is basically the slope of the curve in the stress and strain curve. So as you can see, tan theta is equal to E, which is the slope of the stress and strain curve. The model of rigidity is basically the shear stress by the shear strain, and while the bulk modulus is for the fluid materials only. So the bulk modulus is equal to change in the pressure by the volumetric change, or change in the pressure by density change. So basically what does it mean is, if there is an increase in the pressure, there is a reduction in the volume. So that's why we have a minus sign here, -1, to make the bulk modulus a positive one. So in case we have an incompressible material, in that case the change in pressure is 0. That makes the change in the volume will be 0, which makes the bulk modulus as infinity. So basically the bulk modulus is 1 by the compressibility factor. So next question is, what do you know about elasticity, plasticity, Hooke's law, proportionality limit, etc.? So what do you mean by elasticity? So elasticity is nothing but the ability of the material to deform back to its original shape. That particular property is called as elasticity, while plasticity means the ability of the material to be in a permanent deformative position after applying the load is called plasticity. And this is what we also call as a failure, because we don't want the material to be in this region. So in this, from the picture of from this stress and strain curve, we can see that till this line it is basically the proportionality limit. Only till this portion the Hooke's law is applicable, in which the stress is proportional to the strain, and after this proposition it is called the plasticity region. So next is the factor of safety, FOIS. It's basically the yield stress by the permissible stress. So having the factor of safety is good, because the increase in the factor of safety means more safety. The material is basically more durable, but the negative point is that the weight also increases, the cost also increases. But this is a give and take thing. So for any given design, there should be a factor of safety such that the working model, the stress in the working model shouldn't reach to the ultimate stress. This is the reason we are using the factor of safety. The next thing is the Poisson ratio, which is a property of the material under which, when a particular load is applied in a given direction, there is a change in the longitudinal and the lateral directions. If the lateral strain and the longitudinal is changed, then the negative of the lateral direction by the longitudinal direction gives the Poisson ratio. So if the Poisson ratio is negative, that means the width of the material after the load is applied has increased. So in this case, the honeycomb material is an example. If the Poisson ratio is 0.5, that means the material is rubber. If it is 0.3, that means it is steel. If it is 0, it is a cork. Basically, when you apply the load, the lateral direction doesn't change. So the relation between the elastic constants are K is equal to 9 kg by 3k plus g, E is equal to 2g by 1 plus nu, E is equal to 3k in 1 minus 2 nu. In all these conditions, that means the material is in elastic region, as well as it is isometric, because we will see in the next page what is isometric also. So what is radial and volumetric strain? So as you can see that if the radius of the sphere it changes by the 5%, what is the change in the volumetric volume of the sphere? So as you can see, if it's r, then if the volume of the sphere is 4 by 3 pi r cube, and we can, if we take the log of the formula, then we have this thing, and when we differentiate this, we see that change in the volume is equal to thrice the change in the radius. So the strain is equal to 3 times the strain of the radius. If there is a 5% change, that means it is times 5, it is basically 15 times. If there is change in radius 5%, then there will be 15% change in the volume. This is what it means. Then elastic, isotropic and homogeneous material. What does it mean? Elastic means, as we discussed earlier, that means the ability to regain to its original position of the material. It's elastic. Second thing is isometric. Isometric means the property is same in all the directions. Homogeneous material means the chemical composition is same throughout the material. Second thing is thermal stress and strain. Okay, in a given situation, if we ask that if the strain of the material is 0, does the stress of the material will be 0? Not necessarily. If the external applied load creates a strain of 0, then definitely the stress is 0. But if the thermal strain is 0, there can be thermal stress also. For example, in the given case, see, if there is a rod here and it is fixed between the two situations, and if the temperature changes by delta T, and there is the material thermal coefficient is given and it has a elasticity also, in this case the length is not allowed to change, but the formula, the change in length is equal to L alpha dt, and the strain formula is alpha dt, and given that stress is E alpha dt. So the stress can be calculated, but the strain is not changing because the length is not allowed to change. So in this case, even though the strain is 0, the strength is not necessarily 0.